Did you know that your brain is a master at being tricked? No, really, right now as you're watching this, your brain might be seeing things that aren't even there. Take a look at these two still images. Do you see it moving? Weird, right? Your brain is creating the illusion of motion in a completely static picture. This is just one example of how easily our brains can be fooled by optical illusions. But why does this happen? Hello Brainiacs and welcome to Brainwaves. Let's dive into the fascinating world of optical illusions and how they mess with our minds. Part 1. Introduction to optical illusion. So what exactly is an optical illusion? Simply put, it's a visual trick that deceives our eyes and brain into seeing something that doesn't match reality. Our brain is constantly interpreting the flood of information it gets from our eyes, and sometimes it takes shortcuts that lead to surprising and sometimes hilarious misinterpretations. You see, our brain is a pattern-seeking machine. It's wired to make sense of the world as quickly as possible, even if that means cutting a few corners here and there. Optical illusions exploit this by presenting images that challenge the usual rules of perception, leaving our brains scrambling to figure out what's going on. Part 2. Popular misconceptions about optical illusions. A common misconception about optical illusions is that they happen because our eyes are faulty or broken. But in reality, our eyes are just fine. It's our brain that's the real trickster here. For instance, some people believe that if they don't see the hidden image in an optical illusion, there's something wrong with their vision. The truth is, optical illusions play with the brain's normal processing, not the eye's ability to see. Another myth is that optical illusions are just fun tricks with no real significance. On the contrary, they reveal a lot about how our brains work. They show us that what we perceive isn't always what's out there, giving us insights into how our brains process information, interpret reality, and sometimes get things hilariously wrong. Part 3. How the brain processes visual information. To understand optical illusions, we need to peek into how the brain processes visual information. Our eyes capture light and send this data to the brain, where it's processed to form images. The brain then interprets these images based on past experiences, context, and a bunch of built-in rules about how the world works. But here's the kicker. The brain often fills in gaps or makes assumptions to speed up processing. For example, when you look at a picture of a cube, your brain automatically interprets it as a 3D object, even though it's just a 2D drawing. Optical illusions exploit this tendency by presenting images that lead to conflicting interpretations, forcing the brain to make a best guess. Part 4. Types of optical illusions. Optical illusions come in various flavors. Let's take a look at some of the most intriguing types and see what they reveal about our brain's quirks. Geometric illusions. Geometric illusions play with shapes and spatial relationships. Take the famous cafe wall illusion. In this illusion, a series of horizontal lines appear to be sloping or zigzagging, even though they are perfectly parallel. Our brains use context and surrounding shapes to judge the size, so they get tricked into thinking the lines are different lengths. This is because of the way our brains interpret the staggered arrangement of black and white tiles, tricking us into perceiving the lines as non-parallel. Why do we see illusions differently? The old woman versus young woman is a classic optical illusion that depicts a single image where some viewers see a young woman while others see an old woman. Don't see it yet? The young woman's chin doubles as the older woman's nose, and the old woman's chin is also the young woman's chest. Motion illusions. Now let's talk about motion illusions. The rotating snakes illusion is a popular one. It consists of several circular patterns that seem to rotate when you look around the image. However, if you stare at a single point, the motion stops. This happens because of the way our eyes make tiny involuntary movements called saccades. These movements trick the brain into perceiving motion where there is none. Color and contrast illusion. Let's move on to color and contrast illusions. Have you ever seen the Necker cube? The Necker cube can be perceived in two different orientations, and your brain might flip between them because it can't settle on one interpretation. Now let's move on to color and brightness illusions. The Bezold effect. It shows how the same color can look different depending on the colors surrounding it. Our brain interprets colors relative to the surrounding hues, often leading to surprising results. And who could forget the viral sensation of the dress? Was it black and blue or white and gold? The debate raged on because the brain interpreted the ambiguous lighting in the photo differently. Ambiguous and impossible objects. Ever seen the Penrose triangle? These are classic examples of ambiguous and impossible objects. The Penrose triangle is a shape that looks like it should be possible in 3 dimensions, but when you try to trace it, you realize it's an optical illusion. So why do these illusions trick us? The key lies in how our brains process and interpret sensory information. Context is king. Our brain relies heavily on context to make sense of visual information. Past experience. Our brains use past experiences to interpret what we see. Optical illusions often present the brain with conflicting signals. In the case of motion illusions, the patterns in the image trick our visual system into interpreting the static image as moving, thanks to the brain's attempt to make sense of the visual input. The brain's shortcuts. The brain takes shortcuts to process information efficiently. It jumps between different possible interpretations because both are equally valid, but it can only focus on one at a time. Part 6. Why do we see illusions differently? Well, it turns out that individual differences in brain processing, past experiences, and even cultural background can affect how we perceive illusions. For example, some studies suggest that people from urban environments are more susceptible to certain geometric illusions because they are more accustomed to straight lines and right angles in architecture. Meanwhile, people from more rural environments who are less exposed to these shapes might not be as easily fooled. Optical illusions aren't just party tricks. They offer valuable insights into how our brains work. Optical illusions also show us that perception is subjective. What you see isn't necessarily what others see, reminding us that reality is often a matter of interpretation. Conclusion: the fascinating world of optical illusions. So the next time you find yourself puzzled by an optical illusion, remember that it's not your eyes playing tricks on you. It's your brain doing its best to make sense of a complex world. From geometric illusions to color perception and motion tricks, these fascinating phenomena open a window into the brain's inner workings. And sometimes the truth is, well, an illusion. We hope you enjoyed this deep dive into the world of optical illusions. Thanks for watching. What's your favorite optical illusion? Share it in the comments below. And don't forget to like, subscribe, and hit that notification bell for more amazing content. Until next time, keep your eyes and mind open.